Hi, grade 6. This is a math lesson for lesson 5-2, something called greatest common factor. I know you did this in 5th grade, but we're going to have to do it again this year, and you're going to do it in 7th grade and 8th grade. There are two methods for finding greatest common factor, and so I'm going to show you both methods a number of times. I've got lots of example problems on the board. So let's take a look at 8 and 10. Method 1. I'm going to list all the factors of 8. And when I say all the factors of 8, I mean give me all of the numbers that multiply together to make 8. And I'm thinking 1 times 8 is 8, but I'm also thinking 2 times 4 is 8. You'll notice I try to put them in order from smallest to largest. It makes things easier. 1 times 8 is 8, 2 times 4 is 8. What about the factors of 10? How about 1 times 10 and 2 times 5? Now look at those two lists. What is the biggest number they have in common? The biggest number they have in common is the number 2. So that tells me right off the bat that the greatest common factor of these two numbers is, is 2. Greatest common factor is 2. Now let's get rid of that line. That's not going to help us. But there's a second method of doing this. So first method is you list all the factors and see what they have in common. The second method involves doing a tree diagram and figuring out the prime factorization. If I did a tree diagram of 8, I would find out that the prime factorization of 8 is 2 times 2 times 2. And the prime factorization of 10 is 2 times 5. Remember those things? Here's an example of 10, right? 2 times 5. And here's an example of 8. 4 times 2, 2 times 2 times 2, right? Remember that? We're looking for all the prime numbers. Now, go back up here. What do they have in common? They have a set of 2's in common. And so again, the greatest common factor is 2. Let's try this one right here. What are all the ways you can multiply numbers together to get 6? I'm thinking 1 times 6 and 2 times 3. How about 12? What are all the ways you can multiply numbers together to get 12? I'm thinking 1 times 12, 2 times 6, and I'm also thinking 3 times 4. What's the biggest number they have in common? Actually, they have a lot of numbers in common, don't they? But what's the biggest one they have in common? The greatest one. The greatest one they have in common is 6. So that's one way to do it. I listed all the factors. Now I'm going to do it the other way. I'm going to list the prime factorization of each of these numbers. In my head, I'm doing factor trees. A factor tree for 6 would be 2 times 3, and a factor tree for 12 would be 2 times 2 times 3. What do they have in common? They had a set of 2's in common, and they have a set of 3's in common. See that? What's 2 times 3? 2 times 3, same answer. I get that same answer of 6. Let's do this one. What are some ways I can get to 10? I can go 1 times 10, and I can go 2 times 5. What are some ways? Oh, this one's weird. There's only 1 and 17 as factors. This one's kind of weird. What's the greatest common factor of 10 and 17? It's actually the number 1. 1 is the greatest common factor. 1 is the greatest. That doesn't happen very often, but it can happen. It can happen. Even if I did it the other way. And I listed the prime factorization of both numbers, you notice something? There's not a single thing we have in common other than the number 1. So let's move on to this one up here, 28 and 42. Now it's going to get a little bit more difficult to list all the factors. 1 times 28, I know there's 2 times 14, I know there's 4 times 7. How about the number 42? 1 times 42. How about 2 times 21? Does 3 go into 42? Yes, it does. 3 times 14. I know that's 6 times 7. There's a lot of factors for this particular number. What do they have in common? 1's and 2's. They have 7's in common. They have 14's in common. Oh, greatest common factor in this case is 14. Greatest common factor is 14. But let's do it the other way as well. Let's list the prime factorization after thinking through a factor tree. Here's the prime factorization of 28, and here it is for 42. What do they have in common? They have a set of 2's, and they have a set of 7's. 2 times 7, that same answer of 14. Let's try the next one. 20 and 32. I know 1 times 20. I know 2 times 10. I know 4 times 5. That's about it. How about 1 times 32? How about 2 times 16? 3 doesn't work. 4 works. 4 times 8 works. Any other numbers? Nope, that's it. So I've got 1's in common, 2's in common, 4's in common. Anything else? Nope. Greatest common factor must be 4. But again, let's try the other method. The other method is doing the factor tree and writing out the prime factorization. This one's really interesting because it's just 5 2's lined up in a row to make 32. What do they have in common? A set of 2's and another set of 2's. 2 times 2 is 4. Same answer. Oh boy, are you panicking because you see 3 numbers there? It's really not a big deal. What are the factors of 21? It's 1, 3, 7, and 21. How about the factors for 42? I did this one already, but I erased it up above. 1 and 42, 2 and 21, 3 and 14, 6 and 7. There they are. How about the factors of 63? 1 and 63. 2 doesn't go in, but 3 and 21 works. 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 works. 7 times 9. Oh boy, so what do they got in common? They got a set of 1's. They got a set of 3's in common. They got a set of 7's in common. Do they have anything else in common? Wait a minute, look at this. They got 21 in common. Did you see that? Yeah, sometimes it's tricky. They got 20. So the greatest common factor is 21. Now let's do it the other method and see if we get the same answer. Listing the prime factorization, 3 times 7. For this one, it's 2 times 3 times 7. For this one, it's, let's see, 3 times 3 times 7. What do they have in common? They have a set of 7's in common, and they have one set of 3's in common. What's 3 times 7? 21. That same answer. Okay. Let's go over here. Don't panic. Don't panic. What do you do when they start throwing variables into these situations and they still want you to find the greatest common factor? In this case, you're better off using the second method that I talked about on those 6 problems over there. In other words, the method where you do the prime factorization. So let's write it out using the prime factorization. This one would be 2, 2, 3, p, and p all multiplied together, because p squared is really p times p. And this one would be 2, 3, 5, p, p, and p. Now, let's look at what they have in common. They have a set of 2's in common, they have a set of 3's in common, and they have a set of p's in common and another set of p's in common. So the greatest common factor in this case is 6p squared. 2 times 3 is 6, times p, 6p squared for that one. Okay? If you can do those prime factor trees, it makes it really easy. So 21 is 3 times 7 times a times b, and this would be 2 times 7 times a, nope, times just plain b. What do they have in common? A set of 7's and a set of b's. So my greatest common factor is 7b in this case. Let's go down here. Using a factor tree, I would have 2, 2, 5, a, and a. Using a factor tree, I would have 2, 2, 3, 3 times a. What do they have in common? Set of 2's, another set of 2's, and a set of a's. So the greatest common factor is 4 times a. How about this one up here? 35 is really 5 times 7. And then it would be times the a and times the a. 85, oh yeah, what in the world is 85? 85, I don't know. I know it's divisible by 5 though. So let's do the math work and see what happens. Oh, it's 17. So this is 5 times 17 times a times b. Okay? 17 times 5 is 85. These are both prime numbers. Both prime numbers. Now, what do we have in common? We have a 5 in common, right? And we have an a in common. And that's pretty much it. So my greatest common factor in this case would be 5a. Would be 5a. Okay, 6th graders, that would be it for now. Thank you.